Okay, Saxon 4 math class, we are ready for lesson 84, decimal numbers to thousandths. Okay, let's start with some examples. Example 1, write 375 thousandths as a decimal number. Then use words to name both numbers. Okay, first of all, we're going to take a look at normal place value. And I've taught you guys that if you can read a 3-digit number, you can read any number. You just have to know what to say at the commas and the decimal points. And then when you get past the decimal points, you have to know what place you're stopping at and then say that place. So let's not even start with the decimal yet. Let's go to right here. When we start on the left, you just read this first digit that's in front of the comma and you say 4. Then you see that comma and you say million. So 4 million. Then you say this 3-digit number, 786,253. Now, what if there were more to this number? What if it went this far? When you see a decimal point in a number, that's when you get permission to say and. You know how I've kind of told you it's a really bad habit that some adults have when they say 253 right here. I say don't say and. And means a decimal point. Well, now you know why. Okay? Now, anything past the decimal point, you read the digit or the number, and then you say the place that you stop at. This first place to the right of the decimal point is the tenths. Spell 10, and then you just add THS. So to read this number, we would do what we just did, that whole big number, and 3/10. Okay? But what if it went this far? Okay? You would read what you see here. You would say, and 37 hundredths, because the 7 is in the hundredths place. Notice that THS, it's not just hundred. That would be right here, this spot. You have to be very careful. To the right, you have to add the THS. Okay? What if it went one more place farther than that? Then you would read the 3-digit number you see here, 375 thousandths. You read what you see, and then you tell the place that you're stopping at, okay? So this whole problem, or this whole number, would be 4,786,253 and 375 thousandths, okay? So let's look back at what they're asking us, right? 375 thousandths as a decimal number. So if we do that, this is kind of what it looks like right here. If I get rid of all of this stuff, and this is what we have. This is what it looks like as a decimal number. You can put a 0 as a placeholder here. Okay, most of the time that's what you will see. You will see the 0 as a placeholder. So this is 375 thousandths. This is the decimal form. Okay. Now it asks us to also write that out in words. So we have to write 375 70-5, and then I add the word thousandths. Okay? And you don't even have to say 0 and, okay? Now, if this were a significant number other than 0, we would say, for example, 1 and 375 thousandths. But since it's 0, you don't even have to say it. Okay, example 2. Write each decimal number as a fraction or a mixed number, then use words to name the numbers. So let's look at this one. It looks like this. We know that we don't have to say the 0. We just say 625, that this is the thousandths place. So here's what it would look like, 625 thousandths. Okay, that's as a fraction. We also have to do it using words. So here's how we would spell it. 620-5 thousandths. And don't forget your THS. Okay, if you just say thousand, then you've written this number right here. And that's not it at all. That's totally different from this one. Okay, that's how important those three little letters THS are. Okay, let's take a look at B. 125. And you may hear some people say, well, that's 3.125. And, yeah, it is, but it's not the math way to say it. Do you remember what we say at the decimal point? And, don't we? We say 3 and 125 thousandths. So here's what it would look like if we say that again really slow. 3 and 125 thousandths. Okay? I mean, remember back to when we were saying 3 and 1/2. Okay? It looks the same, doesn't it? 3 and then you have your fraction. Okay, so let's spell that out. We would have to say 3 and, cannot forget the and, 120-5 thousandths. Okay? And every single word is important. Okay, moving right along. Okay, let's look at this verify. Explain why 625 thousandths is greater than 325 thousandths. Okay, well, a simple way of looking at this, if we look at just the 6, if we knock off the 2 and the 5, that's knocking off 2 digits. If we knock off 2 digits down here, we would be looking at 6/10. If we did the same over here, we would be looking at 3/10. Hey, 6/10 is bigger than 3/10, right? It's the same idea. If you have a pizza and it's divided into 1,000 pieces, each piece is called a thousandth, okay? Would you rather have 625 of them or 325 of them if you're really super hungry? Let's pretend it's a regular Papa John's pizza and that is cut into 1,000 pieces. They are going to be teensy weensy. So I'd rather have 625. Okay. Lesson practice. Write each fraction or mixed number as a decimal number. So first we're looking at fractions and we're going to switch them to decimals. So let's look at A. 425 thousandths. Okay, here's how we started. Go ahead and put your 0 point. Okay, then write 425 and you're to the thousandths place. Okay, tenths, hundredths, thousandths. So this is what it equals as a decimal. Okay. Ooh, we've got a mixed number here, a whole number and a fraction. So here's what this would look like. 3 and 875 thousandths, because I stopped at the thousandths place. I'm getting tongue-tied. Okay, now let's look at this one. Okay, this one's trickier. Okay, we know that we have to stop at the thousandths place. So here's what I want you to do when that happens. Go ahead and put, we don't have a whole number, do we? So I'm going to put 0 as that placeholder and. Now I know that I've got to go all the way to the thousandths place. How could I do that and still just say 35? I'd have to put a 0 right here, right? because this is the same as 35, isn't it? I've just taught you guys to leave that off. Well, in this case, you need the 0. If you put this, then you have 35 tenths. I'm sorry, hundredths. You have 35 hundredths because it goes to the hundredth spot. So be very careful. That's very different from 35 thousandths. A thousandth is a lot smaller than a hundredth. Okay. And now let's look at this one. 2 and 7 thousandths. Okay, again, we do have a mixed number. I'm going to go ahead and put whole number 2 down. But now I have to put 7 thousandths. So I'm going to say, okay, 2 and I know I have to go to the thousandths position. Okay. If I put the 7 here, I've got 2 and 7 tenths. If I put it here, I've got 2 and 7 hundredths. I have to put it here. I have to put it in the thousandths position, okay, because that's what it says. Now, what's going to go right here and here? You got it, zeros. So this still says 2 and 7 thousandths because it went to the thousandths position. Okay, now let's look at E through J. Write each decimal number as a fraction or mixed number, then use words to name the numbers. Whew, okay, so some spelling practice here. Let's look at E. I hope I remember that. Okay. Now we have to turn this into a fraction. So this side we're going to do decimals, fractions. My pen's not cooperating. Okay, 0 and, that means I don't have a whole number. This is not going to be a mixed number. It's just going to be a fraction. I read what I see, 214, and it stops at the thousandths place. So it's 214 thousandths. And how would I write that? Here we go. 214 thousandths. Okay, 214 thousandths. Now let's try F. Okay, first we have to change it into a fraction. So we say 4 and, so I know 4 is going to be my big whole number. Now 321 thousandths. And here's how you spell it. 4 and 320-1 thousandths. I hope I can fit it in here. I did, just barely. Now let's take a look at G. Ooh, look at this, it's tricky. Make sure I copied it right. Okay. Since it's 0 and, I don't have to put anything, do I? I don't have a big whole number. I'm just going to have to make a fraction out of this. So I read what I see, 25, and I stop at what position? Thousandths. So here's what that would look like in spelling. 20-5 thousandths. Okay. Now let's look at H. we have to say 5 and then I read what I see, 12, and I stop at the thousandths position. So here's what it looks like, 5 and 12 thousandths. Here's how you spell it, 5 and 12 thousandths. Come on, pen. All right. Ooh, look at I. Okay, I don't have to say 0 and. I can just write the fraction. So I read what I see. I see a 3. And it's in the thousandths position. Ta-da! 3 thousandths. And one more. This one's fun. Okay, we've got 9 and then the fraction. So I'm going to put a big 9 for my whole number. And now I read what I see. I see 999. And I stopped reading at the thousandths position. So it's 9 and 990-9, hang on, thousandths. Ah, just barely fit it in. Okay, let's go back. I know you need to check your 83 written practice. So hit pause as you check 1 through 7. Sorry about that little bleep. It wouldn't come up for me. Now hit pause as you check 8 through 16. Hit pause as you check 17 through 25. And hit pause as you check 26 through 30. Okay, now we're going to go and do some mental math. Counting by fives from 1, 2, 3, 4, or 5, we find 5 different final digit patterns. Okay, so if you start with a 1 and you add 5, you get 6, right? If you start with 2 and you add 5, you get 7. 3 and 8, 4 and 9, and 5 and 0. Now, when a number ending in 5 is added to or subtracted from another number, the final digit of that number and of the answer will fit one of the 5 patterns. Okay? Look for the final digit pattern as you solve A through F. 22 plus 5. Well, hey, look, the 2 goes with 7. So it's 27. Now, 22 minus 5, we're still going to hit 7, but it's going backwards. 17. 38 plus 5, 43, because your pattern is 3 and 8. Okay, 38 minus 5, 33. 44 plus 5, we see the 5 and the 9 go together. And 44 minus 5, we're still going to see that 9, but it's going to be going backwards this time, so it'll be 39. Estimation. Estimate the percent of this circle that is shaded. Well, it's less than 50%, isn't it? Okay. Now, half of 50 would be 25, so it's somewhere between 25 and 50. So make your guess. About 40%. Okay, let's do some calculation. Square root of 36, that's 6 times 3. 18 plus 10, 28 divided by 4. 7 minus 1, 6 divided by 3 is 2. And you are finished. I lied, you're not finished. We've got problem solving. Tanner has 3 homework assignments to complete. One assignment is in math, one is in science, and one is in vocabulary. Tanner plans to finish one assignment before starting the next. What are the possible sequences in which he could complete the assignments? So math, science, and vocabulary. Math, science, and vocabulary. Now, if he starts with math, he could do science and then vocabulary, or he could switch the vocabulary and the science. That's one possibility. I mean, actually, we have two. Let me bullet these. But what if he decides to start with science, my favorite subject? He could do science and math and vocabulary, or science, vocabulary, and math. But what if he decides to start with good old vocabulary? He could do vocabulary, math and science, or vocabulary, science, and math. So we have through 6 different ways, different combinations. Okay, now you're finished.